Howdy, howdy, this is Mr. Potter. In today's video, we're going to talk about using Linux to deal with jobs, memory, and disk management. So I've written a small file here, million.cpp. And all that it's going to do is it's going to count up to 1,000,000 and then print out 1,000,000. Now I've written this in C++ because C++ writes very effective, very efficient code. And this loop is just going to keep on going forever. And so we're going to be talking about how to deal with jobs in the Linux shell, because Linux can really multi-thread tasks. It can run multiple programs simultaneously. And of course, you're used to that when you're on a desktop, but you can also deal with that from a command line situation because it can run multiple things, not only in the foreground, but in the background at the same time. So I'm going to run this program by just doing /. That means I'm running in my current directory, million.exe. Now realize what this program is going to do is basically count 1 Mississippi, 2 Mississippi, except computers count Mississippi very fast, up to 1,000,000 and then print out 1,000,000. And then it's going to move on to the next line, and it's going to keep doing this until someone tells this to stop. So I'm going to run million.exe, and that means it's going to count to 1,000,000 and print 1,000,000, and my goodness, it's fast. I mean, look at that. It is essentially, I'm pressing the L key just trying to get that up, and you can see over here in the corner where my CPU usage is just really ballooned up here. So I'm going to hit ctrl-c. Ctrl-c will stop the current task or the foreground task if I'm in the Linux shell. And then I also have the option of running software in the background. So I can do that same command, million.exe, but I can add an ampersand to the end of this. And what this does is this tells the Linux shell to run this in the background. So now it's running that 1,000,000 over and over and over and over and over again, and I can't stop it. It's in the background, so I can actually run other commands here. I just did an ls command, but it scrolled off the top of the screen. I can do a lot of different commands, but even if I do Control-C, it's not going to stop the program. What I have to do is I have to return it to run in the foreground. So I'm going to type FG and then hit Enter, and now my program's running in the foreground. And now I can hit Control-C, and it will stop. So what I did is I did FG, and that made whatever program was running in the foreground, in the background, make it run in the foreground so that I could control it with my keystrokes. Now I can tell you this million program is very unreasonable. So I have another program called billion, and it does the exact same thing, except it's counting to 1,000,000,000 before it prints out 1,000,000,000 on the screen. So if I run this, it should run about 1,000 times slower. And of course, because it's running so slow, I can hit Control-C and it stops. I can run billion in the background, and I can see that I can run ls command. I can I can go into my source directory. I can keep working as if I'm in the Linux shell, because I am. This program is just running in the background. So now if I do an ls, I'll see the source file for all the files we're going to be using today. And I can cat billion.cpp, and I can see there's my billion program. You can see that it's counting up to 1,000,000,000. Of course, that's a little too slow. So what I'm going to do is I'm going to type FG again to make it run in the foreground. And then I can do Control-C to stop this task. What I want to do is I want to run something that's a little bit faster. Now, in Indian counting, there's something called a crore, and a crore is essentially 10 million. So if I do cat crore.cpp, you'll see that it's counting up to 10 million. And so if I run my crore program, I'll see that it runs 1/10 the speed of the millions program that we ran, and it's still very, very, very fast. I mean, if I try and run this program in the background and then try and do other stuff there, I just did an ls, but it scrolled off the screen too quick. If I try and do Control-C, you can see the Control-C's on the screen, but they scroll off the screen too quick. What I need to do is make sure that I'm running it in the foreground by pressing FG Enter, and now you can see that it's running in the foreground, and Control-C will stop it. So the question is, what if I already have a program that's running in the foreground and I want to run it in the background? Well, I've got another program here called Wan. And in Chinese, Wan is 100,000. It's basically a myriad, or 10,000 10,000s. And so this is going to run, again, a tenth as slow as the crore program, or 100th as slow as the million program, or 10 times as fast as the billion program. And this one's actually fairly reasonable for the system here. I can see it running. And what I have is the ability to suspend a task. In other words, to stop the program that's running without killing the program. And what I do is I do Ctrl-Z. Now, in order to do Ctrl-Z on Cloud 9, I have to do Ctrl-Shift-Z. It's one of the quirks of Cloud 9, but on almost every Linux command line, Ctrl-Z will stop the task. Now, notice it says stopped. If I were to do FG, I will see that it's going to continue that program. So what's nice about Ctrl-Z is that it doesn't terminate the program. It just suspends the program. So what I can do is I can do Ctrl-Z again, and now from this command line, I can run my billion program in the background. And that means that it's going to be saying billion every time. But notice that I have two jobs here. As a matter of fact, if I ever want to see all the jobs on my system, I can type JOBS, and it'll tell me all the jobs. Notice that I've got one, which is stopped. This is the Wan program. And I've got my second program, which is currently running, which is billion. Now, if I do Control-Z again, it's not letting me do it for some reason, not sure why. So let me go ahead and do this. Let me do foreground 1. I mean, in other words, I want to run program 1 in the foreground now. And so now it's going to run 1 at the same time billion is running. And so what you'll see is that it counts 10 1 every time it gets a billion. So in other words, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there's a billion. And so I see 10 of these 1 every time I see a billion. Now, if I hit Control-Z, that's going to stop the Wan program, which was running in the foreground. I still have billion running in the background, so it's still running the billion program. And if I want to kill that, I could put it in the foreground the way we did before. But the other thing that I can do is I could tell it to kill that program. I can do kill %2, and that will kill that program for me. So let me do that again. What I'm going to do is I'm going to run two programs in the background. I'm going to run crore in the background. And I'm going to run Wan in the background. So notice that it's counting out 10 crore and then it's doing a 1, 10 crore and a 1. If I do jobs, J-O-B-S, it's telling me the jobs. And I see that I had two jobs up here. So if I do KILL space %1, then it's going to kill the first job, which was crore. And so now I just have Wan. Now if I do jobs, it's going to tell me, hey, job 2 is still running. And so I can kill that job, or I can suspend it. So let me put it in the foreground, and then Control-Shift-Z to suspend it. So I've got this ability to kind of run stuff in the background as well as run programs in the foreground. I can see them overlapping what I'm doing. I can navigate the Linux command system exactly the same way as I could before. The only difference is that it clutters the screen up, certainly. However, if you're remotely logging into a system, you might have a web server running or a mail server running or some other type of service running. And you can actually find the jobs not just running in your command prompt, not just running in your little console, but you can actually find the jobs that are running on your entire system. And the way that I can do that is by typing PS. Now, PS stands for processes. And if I just type PS right now, it's going to tell me all the processes that are running in this particular window. So right now, notice 1.1 is still running in the background. It's just been suspended, but it's still running. It's still taking up memory. It's still taking up space in my computer. And it has a process ID of 3506. Now I know that if I wanted to kill it, I could do kill %2. But if I want to kill something that's not running on my system, I can actually kill it by doing the command process. I can tell it to kill 3506. And what that does is that's going to kill 1.1. So if I try and FG or foreground it, notice it tells me, hey, that program was terminated. If I do jobs, I'm going to see that there are no jobs running. And if I try and do PS to list all the processes, I notice that the 1.1 process isn't running anymore. So I have this ability to see what's running on the system at any time. Now what I'm going to do here is I'm going to run billion in the background, and then I'm going to run one more program called top. Now what top does is it tells us all the processes that are running on my system right now. Now I'm running as a user named Ubuntu, so I see I've got billion.exe, I've got tmux, I've got bash, which is my command system, and then of course the top program as well. But I can also see what percentage of the CPU it's using. Right now this is loading up my computer, so it's really packing it in. I'm using 99.5% of my CPU. I can see how long it's been running. This has been running for about 37 seconds. And what's nice about this program is that it runs continuously in the background. So I have two things that are running right now. One is the billion program, and one is top. Out of 10 total programs, because I got 10 listed here. Now this process ID number 1, this is my initialization. Process IDs with very low numbers, or process IDs with root, are the ones that are run by the system. I don't have as much control over those. The system has control over it, but I have control over anything with Ubuntu on it. So what I'm going to do is I'm going to do ctrl-shift-z, which runs top in the background. And what I can do is I can force it to run in the background continuously. I can do BG, just like I did FG. Now, it's not going to like me running top in the background because it wants to have control of the screen. So I'm just going to go ahead and kill that process. What I want to do is I want to run ctrl in the background. And I'm going to do ctrl-shift-z and put it in the background. So now billion and ctrl are both running at the same time. Remember, ctrl is running at 1/100th the speed of billion, so it's actually running that fast. And if I do jobs, I can see the jobs that are running. If I do top, then it's going to tell me the top processes. And this screen, remember, refreshes every 3 seconds. But ctrl and billion are going to make it run off the top of the screen very quickly. Now I'm going to look real quick and see if I can find the process number. I see a 3562. So if I do kill 3562, nope. 3546, 3546. Nope, that's not working either. So let me just go ahead and kill %2 then. Oh, because top is running. That's the problem. So if I do kill 3546, so now just ctrl is running. Billion shouldn't be running anymore. If I do jobs, I should get confirmation of that. I only have one job running. And then what I can do is I can kill %2, and that's going to stop ctrl. So I have this ability to control programs that are running both in the foreground and in the background. Ctrl-z and Ctrl-c are two ways to kill the process. Ctrl-c actually kills it, actually stops it, and Ctrl-z will just suspend it, have it hold its place in memory without really advancing anymore. We've talked about a couple of ways that I can view what's currently running on the system. So we have jobs, and jobs will tell me everything that's running in the current session, but I also have PS, which stands for processes, which will tell me all the processes that are running on my system. And I can actually do PS with a -UX, and that'll tell me all of my processes. Remember that when I did top, I saw that there were 6 of mine and 4 of root. So this actually lists all of them, including anything that's running in the background. So I've got this tmux that's running, which is actually my connection to this Cloud9 instance. I've got 2 different bashes running. I've got this ping interval, which I'm not sure what it is. And then, of course, the current process that I'm dealing with. So I have this ability to look at processes both in my current session and any of my processes that are running in the background. I can even do PS with -AUX, which should give me everything, including roots. And notice that it's in order by process ID. I can see how much CPU space it's using. I can see how much memory it's using. So I'm going to go ahead and clear my screen. And I'm going to run the million program, but I'm going to do it in the background. And I'm going to redirect its output to a file. And of course, what I'm doing with this greater than sign is I'm saying everything that would normally show on the screen, instead, place it in this file. And do it in the background so I can do other things right now. So I'm still running that million program, but what's happening is it's storing the results on the disk. So notice that I'm using the CPU. I'm not using it up fully because this program's running in the background. But I've created a file called million.txt. And if I wanted to cat that program, txt, I can see it's a pretty long program. As a matter of fact, we can use the grep command we talked about last time with a -n, and I can search for the letter A in million.txt, and what it will do is it'll put line numbers. So I've already printed out 5,695 of these millions in that text file. And so this is going to continue to run. But what I want to talk about now is I want to talk about disk management. So Linux has a couple of things that we can do to deal with disk management. And the first one we're already familiar with. I know that ls will list the files, and I know that I've got this file called million.txt, and I know it's getting bigger. So what I can do is I can do ls with an L flag, and what this is going to do is it's going to give me the long listing. And so what I notice is I see how much memory each one of these files are taking up. So this is taking up about 9K worth of memory because I'm dealing with million. And this is taking up 2 less because crore is a smaller word. Remember that it's printing that word on the screen multiple times. Billion's about the same as million, so it's taking up the same amount of space. 1 has a different issue with it. I think it's because of these Unicode characters that I'm using. That's what's being printed on the screen. If I run this command again, you'll see that million.txt has changed size. It's actually gotten bigger. It's in the process of getting bigger. So I have this concept of ls, list files, with the -L, which allows me to list not only the files, but also how big they are, who owns them. Remember, I'm running as the user named Ubuntu, and some other information which we're going to talk about later. But there's 2 other commands that I can use to deal with disk management. One is df for disk free. This is going to tell me about how much free space I've got on my system. Now I currently have, according to this, I've got about 2 meg of free space available, and I'm using up 4,440K of this in my local. So notice I'm using up about 1% of the hard drive space that I'm allowed on this instance of Cloud9. df tells me the disk free. This tells me how much free space I've got. Now notice this is how much I'm got in total, and I'm using up this amount, and I have this amount available. If I run this command again, remember that million is still running in the background, so that million.txt file is getting longer. So I'm using more, and I've got less available. So df tells me how much disk space is free. There's one other command, which is du, which is disk space used. Now if I just type du, it's only going to tell me about the directories. So I know that I'm using about 20 for my source directory and about 392 for the current directory. If I do du with a -h, it's going to give me something that's a little bit more human readable. That 20 is really 20K of space. In other words, 20,000 bytes. And my current home directory, that dot, is using about 416K. And of course, if I continue, I can see that 436. And just as before, I could do the exact same thing with the wildcard. So I could do .exe, and it's going to tell me how much each of those executables are taking up in hard drive space on my machine. Now, even though those files, remember, were ranging between 9136 and 9139 in the actual bits that they're using, this instance of Linux uses a 4K cluster. Basically, each file comes in 4K groups. So in order to fit 9 kilobytes of memory, I have to use 3 of those clusters. So it's telling me that, hey, I'm using 12K for each of these files. And if I do du with my human on everything, I can see how much every file is currently using. Including my source directory. It says that I'm using 20K in my source directory. So let me change that source directory. And let me do du human here. And I can see each of those is using 4K. Well, 4 plus 4 plus 4 plus 4 only adds up to 16. Keep in mind that the folder itself, source, that directory, takes up a unit of 4K. That's the 20K that source is taking up. So what we've talked about today is we've talked about jobs in memory, and we've talked about disk management. Remember that jobs in memory, I can talk about using ctrl-c and ctrl-z. Those will completely terminate a task or suspend a task so that I can run it in the foreground or the background. I can do FG when a task is in the background to make it run in the foreground. And I can do BG to force a task to run in the background. I can also use the ampersand when I run the file to force it to run in the background when it starts. We talked about how I could use jobs to list the current jobs that are running on my session. And we also talked about how we can use PS to list the processes that are running on the current instance. We talked about how I can use top, which is a nice way to keep track of what programs are running on a continual basis as opposed to just the snapshot that jobs and PS gives us. It also tells us how much memory it's using and how much computer cycles it's using. And we also talked about how I can kill procedures. I can kill processes by giving the PID. So we did kill 3546, and that killed billions when it was running earlier. Or I could also kill a particular job using the jobs listing. So I can kill the second job or the first job. The other thing that we talked about today is we talked about how we can use ls with the L flag, and that gives us a long listing. This tells us all the files along as how much space they're actually taking. Well, that's not interesting. Let's go back to the previous directory. Wow, that million file is starting to get a little bit pretty big. Almost a meg. We also talked about df, which tells us how much disk space is free. And we also talked about how to use du for disk usage, which tells us how much space our files are actually using. And notice that the difference between what we see in our long ls listing and what we see through our disk usage is the fact that disk usage uses up blocks or uses up sections of the disk at a time. I can't just use 9K of memory. I have to use them in 4K increments. So once again, this is Mr. Potter. Thank you for watching. Have a great day.